Good day, everyone. I am Joshua Oportuno, and today we're going to answer a few questions from the past laboratory that we have conducted during the biochemistry laboratory. And let's now proceed. So before that, I like to share about my takeaways from this video that I learned a lot from the Lewis structure and how to conduct it and the molecular geometry, but I am still struggling with a few questions like it is really a trick for me and hard to understand. And that is it. Let's now proceed to the questions.
Now we're going to the steps to draw a Lewis dot structure for a polyatomic ion with a negative charge. First, we're going to determine the total number of valence electrons, and we're gonna use the nitrate ion to identify how to draw a Lewis structure. First, we should count the total valence electron of each atom. So nitrogen has 5, 1, 2, 3, 4, 5, and oxygen has 1, 2, 3, 4, 5, 6. And so the next one is we're going to arrange the acids. So we will place the nitrogen at the center, surrounding by 3 oxygen. So the next step is we're gonna distribute the electrons. So mm, oxygen has 6. So one, 2, 3, 4, 5, and 6. This one has 1, 2, 3, 4, 5, 6. And for the top one, we're gonna distribute electrons form a multiple bonds to complete its octet. Bracket.
The VSEPR theory helps predict the shape of the molecules by considering the repulsion between electron pairs in the valence shell of an atom. According to this theory, electron pairs, both bond and lone pairs, around the central atom will arrange themselves in a way that minimizes repulsion, resulting in a specific molecular geometry. This theory provides a simple yet effective way to predict the shapes of molecules based on the repulsion between electron pairs around the central atom, helping to explain the molecular structures and bond angles in a variety of compounds. So let's use VSPEPR theory to predict geometry and polarity of molecule NH3. Step 1 is to count the valence electrons of nitrogen and hydrogen, which is 5 and 1. And since there are 3 hydrogens, so we're gonna add 5 and 3 with a total of 8. Next step is to determine the electron pair geometry. Nitrogen in NH3 forms 3 single bonds with hydrogen atom, leaving 1 pair of electron in nitrogen. Therefore, there are 4 electron pairs, 3 bonding pairs, and 1 lone pair around nitrogen atom. We're gonna apply the BSEPR theory with 4 electron pairs around central nitrogen atom. The electron pair geometry will be tetrahedral. However, because one of these pairs is lone pair, the molecular geometry is trigonal pyramidal. The lone pair does not contribute to the molecular shape. Step 4 is to determine the bond angle, which is approximately 107 degrees. And since the molecule is asymmetric, due to the lone pair, the dipole moments do not cancel out, resulting in a polycular molecule. Electron domain geometry considered all electron domains, bond, and lone pairs around the central atom. For H2O, it is a tetrahedral due to 4 electron domains, 2 bonding pairs, and 2 lone pairs, while molecular geometry focuses only on the arrangement of atoms, ignoring lone pairs. For example, H2O, the molecular geometry is bent because the 2 lone pairs repel on the bonding pairs, reducing the bond angle to 104.5 degrees. The influence of lone pairs on H2O. The lone pairs occupy space and exert repulsive forces, altering the shape from tetrahedral to bent, which is crucial in determining the molecule's properties.
For me, my main struggles that I still need to overcome in this topic is the polar and non-polar and getting the angles, because it is really complicated for me and my brain is still adapting from the situation, and the different questions about geometry and chemistry. And with the help of I overcome it by guiding me and my knowledge to accommodate more info about geometry and the non-polar and polar thing. That's it. Thank you.
Since molecular polarity affects how substances behave in ecosystem, it is essential to understand an environment in science. Because polar chemicals dissolve in water, aquatic creatures, dispersion and bioavailability are impacted. This information helps in assessing of the ecological impact of contaminants, the prediction of pollutant transport through soil and water, and the creation of focused remediation techniques. All things are considered. Environmental protection and efficient pollution control depend on an understanding of molecular polarity.